Friends, this video is going to be done to completion of the previous lecture. Last week I have gone through the 2012-2020 paper, and this is the 2019 one, which is the first paper of your new syllabus, structured number 1. Right, let's start. The following questions are related to the elements of the second row in the periodic table. Second row, right? Second row. Write the symbol of the element in the space provided in the answer is of 1, 2, 5, 6. I have quoted 2 in here. Identify the element that has the highest electronegativity. Disregard noble gas. Yeah, normally we are not taking the noble gas because they won't form covalent bonds except xenon. Then there are some radon, also some noble gases which can form covalent bonds now, but helium, neon, argon does not form any covalent bonds at the normal conditions. Therefore, this is the thing you should write. I have told you that when we are going to the exam in the rough paper, you should write this thing at first. This is the Pauling scale. It is easy to memorize. 1, 1.52, 2.53, 3.54. This is running for 0.9, 0.1, 0.12, 1.5, 1.8, 2.1. Then there is a small difference, 2.5 and 3. Between these only 0.3 difference, but at here you can see a 0.4 and 0.5 difference. But there, this is a regular pattern, 0.5 each. Okay, just only you need to in here consider the second row. Therefore, the highest electronegativity is the fluorine, which has the highest electronegativity in the whole periodic table, fluorine. Identify the element that has the allotrope which conducts electricity. You know, there are 3 major allotropes of carbon, which I was explained in the previous theory class in 2022. This is the graphite structure. Graphite. There is a good proper picture in the resource book, but for our ease of understanding, this kind of structure can be drawn. In here, these dots are delocalized free electrons or delocalized pi electrons. It means this carbon is sp2 hybridized carbon. Therefore, the presence of you can see the presence of free electrons in each carbon atom. Hence, the electricity can be conduct along the planes of graphite. Plane එකක් කරහා විතරයි ඇත්තට මේ electricity ගමන් කරන තල තියෙනවා. දැන් මේ වගේ if you draw the 2D structure, this is a somewhat plane of. In here you can see these structures, like the electrons are in these planes. Another plane I will draw here. Likewise, these structures are here. Okay, the free electrons are here. Okay, another plane I will draw. Likewise, this is a covalent gyre lattice. These are planes of graphite. In between these planes, there are London forces. These are London forces. To hold these planes, there are London forces. London forces. But the electricity will transfer along planes to the vertical direction, not the horizontal. Sorry, the horizontal direction, not the vertical direction. Okay, along the planes. Right. Electrons. When there are free electrons or free ions or both of them present in a structure, under the potential difference, the electricity can be transferred. That is why these graphites, despite they are non-metals, graphite still transfer electricity. That is the exceptional property of graphite. Not diamond, Diamond structure is sp3 hybridized structure. You can see in the resource book. It won't transfer electricity. Even though fullerene is sp2 hybridized, there is no evidence that fullerene is transfer electricity. But you should remember that in fullerene carbon structure, all the carbons are sp2 hybridized, which is not in your syllabus, which is not in the resource book. But you should remember that. Okay. Then therefore, the element had the carbon. You have to. They have asked, write a symbol. If you write carbon in here, it is wrong. Marks will be deducted. If you write in fluorine in here, the marks will be deducted. That is wrong. You have to put the symbol that they have mentioned, special in bold letters, symbol. You have to consider these bold letters. Okay. The Roman 3 and Roman 4, 2019, structured 1. Identify the element that forms the monoatomic iron largest in size. Last week I gave you this short note. If you consider the negative ions of the second row, N3 minus is smaller than O2, larger than O2 minus. Likewise, the nitrogen is larger than oxygen and fluorine. Likewise, but if you consider both these, the negative ions, it means anions are larger than the ground state atoms. Okay, that's if you consider the positive ions, it means cations with the corresponding atoms. The atoms are larger than the cations. Like this is the you should remember this thing. This is a short note. If you consider only the anions and cations, anions are larger than the cations. Right? මේක ඇති. මේක විතර මතක තියාගන්න. ඒක එන හැටි පොතේ තියෙනවා ඉතින්. This is the short note. No, if you want a big theory, you can go for the resource book or your class note. Identify the element that forms the monoatomic largest in size is, you can see that this one, monoatomic iron largest in size, which is in the second group, second period. They are asking about the second period, second row. Therefore, nitrogen is the one. There should be a stable ion. They have mentioned that. Therefore, N3 minus is the largest ion. Therefore, you should write nitrogen in here. Monoatomic element. They asked to identify the element. Identify the element that has no p electrons but has a stable s configuration. This is used beryllium, because 1s2, 2s2 is the electronic configuration of beryllium, and the s configuration is stable. It means s is fully filled. It is not the lithium, because lithium has 1s, 2s, 1, only one electron is filled. Therefore, the beryllium is the answer. After beryllium, it is boron. Boron is 2s2, 2p1. It means the p electrons have been started. Therefore, this is the correct answer, beryllium. Okay, move. Fifth one, identify the element that has the highest first ion acid. This is the other diagram you should draw in your rough paper after the electronegativity series. In your rough paper in the exam, you have to draw this also. No need to memorize the numerical values, just the pattern. Just the pattern. Okay. Identify the element that has the highest first ion energy, means neon. This is regarding the second row. No? Neon has the highest. Very easy. These are very easy. Identify the element forms the mostly electron deficient trigonal planar covalent bonds in your experience. If you have done the enormous amount of past papers from 2000 to 2020, these are very famous questions. Very famous questions. Due to your experience, you will definitely draw this BCl3 element that forms mostly electron deficient. If you consider the third period, it should be aluminium. But you can, in here you have to consider second period. They have mentioned it earlier. Second period. Therefore, the boron is the element that form the electron deficient. Electron deficient, it means octet is not fully filled. In here you can see only 2 electrons, 2 electrons, 2 electrons. It means altogether 6 electrons in there, not 8 electrons. You know that the second period cannot overcome the octet rule, but this is somewhat stable because it won't overcome the octet rule. Octet rule එක overcome කරලා නැහැ. electron 6ක් තියෙනවානේ. 8 පැනලා නැහැ. ඒක නිසා මේක somewhat stable but not actually. octet එක fulfill වුණොත් තමයි ගොඩක්ම stable වෙන්නේ. But this is actually a somewhat gas in nature. BCl3 actually at normal condition, atmospheric condition, it is a gas with a pungent odor. I think ඔගොල්ලෝ ගොඩක් මේක ගැන දන්නේ නැහැ. It's a gas. It's a LCl3 also somewhat gas. Right, at the normal conditions. BCl3 also like that. And in the resource book, they said that boron and aluminium compounds with incomplete octet form dimers in the gaseous space. They form dimers. In the example, they have given an aluminium fellow like this. The chlorine donated one lone pair to aluminium, and here the chlorine donated its lone pair to the aluminium to form this dimer. And they say the boron also doing that. But if you consider, in fact, boron Cl3, the dimers of dimerization of boron is less than AlCl3. Dimer formation of AlCl3 is comparatively high, comparatively easier than in BCl3. You should remember that. BCl3 dimers හදනවා gaseous space එකේ, but the formation of AlCl3 dimer is somewhat easier rather than boron, because due to the aluminium is somewhat larger in size. Boron is somewhat lesser atomic radius. Boron has a lesser atomic radii. Okay, and also that is not the true correct answer. Actually, you have to go beyond that. The dimerization of AlCl3 is somewhat easier actually because due to the atomic radius is high. That's true, but due to the presence of d electrons, due to the presence of d orbitals, due to the presence of d orbitals, because if you write the electric configuration, it is 1s2, 2s2, 2p1. The third principal quantum number is not still started, but if you consider aluminium, 1s2, 2s2, 2p6, 3s2, it is 3p1. It means the 3 has been started. Therefore, you know that there are 3d note also. 3d in the principal quantum energy 3. There are 3 sub energy levels, which are S, 3p and 3d, but 3d is not filled. But if someone provide lone pairs, there are plenty of space to accept those electrons. That's why aluminium is more easily prepare the dimers. That's why this is somewhat sp3 hybridized, but at some times the electrons can be filled into 3d also, because 3d subshells are larger in size. There are some exceptional things in these kinds of structures that which are not in your syllabus, but you should know this. Dimerization is somewhat powerful in AlCl3 rather than boron. That's need to be remembered, right? Okay, because due to the presence of d orbitals in aluminium. And if you consider the boron fellow, in here I have quoted some from the mother resource book, the resource book which is used to prepare your resource book, right? Is quoted from it. The tendency to behave as Lewis acid decreases with the increase in the size down the group. It means that BCl3, AlCl3 can act as Lewis acids because they can accept lone pairs. Lewis bases are who donate lone pairs, like ammonia. Ammonia is the best Lewis pair in our syllabus, is the best. But they say that the liking to be act as a Lewis acid decrease down the group when the cation or the atom is increases. It means the Lewis acidity is somewhat high in BCl3 rather than AlCl3. This is this is another story, and this is another story. Both there are two different stories. In here, dimerization, this is regarding the Lewis acid liking, willingness. Okay, if you consider this ammonia, this kind of structure can be formed, this kind of complex. The boron, the shape around the boron is somewhat tetrahedral. Okay, those are the things you should be remembered. To the formation of this complex fulfill the octet also, right? Dimerization also be done to fulfill the octet. You can see that now aluminium is 2, 4, 6 and 8. Around the aluminium also you can see now octet is being fully filled. Okay, stories මේ විදිහට මේ අදාළ points හරියට ඉගෙන ගන්න. එතකොට මේවා ලේසි. Right, it means this is boron. Okay, boron. Boron. Right, let's go to the next part. This is last week I have explained about how to draw the resonance structures correctly. Okay, but in here you can see sulfur is present. It means it is in the third row. No, sulfur is in the third row, that period. It means if they asked to, in here they have only asked to draw the most acceptable Lewis structure. Lewis structure එකද ඉන්න පුළුවන් වුණාට මේවයින් resonance අහනවා අඩුයි. I told you that in the past decade only one time they have asked about, 2 times or they have asked about the asked to draw the resonance to these kinds of third period elements, because I will draw some resonance structures for this also, but despite they have not asked, but I will draw. එහෙම දෙන්නේ නැත්තේ මොකද එහෙම අඳින්න දුන්නොත් ගොඩක් වෙලා යනවා. අඳින්න ගොඩක් අඳින්න පුළුවන්. In here also you can draw 1 2 3 4 5 6 8. I will draw. It cannot be, I have drawn in a separate paper with me, that's why I know about 3 4 5 6 7 can be drawn. Let's draw. First draw the most acceptable with dot dash. In here you can see that this is the molecule formula, SO3F2, and there is no charge. The overall charge is 0. It means no ion charges should be there. Overall charge should be 0. Therefore you have to consider the most electropositive one, the sulfur. That's why it is in the middle, and we cannot consider these are some high atomic molecules. No, the skeleton should be given. That's why they have given that. Okay, sulfur is there. Fluorine, oxygen, fluorine. I told you previously oxygen can be only like this, or like this, or like this, only like this. And here you can see there is no charge. It means this should be like definitely like this. Fluorine only, the valence of fluorine is 1 always. This is the 17th group, that's why this cannot be changed. The oxygen is in like this, but we know that this overall charge is 0, hence you go for the double bond. Right, fluorine is single bond always. Now if you consider the octet, there is 4 4 8 and 2 and 2 here electrons around the sulfur. 4 8 10 12 sulfur's octet has been overcome, but it does not matter because sulfur can bear up to 18 electrons because it is in the third period. Hence this is correct, this is true. If you consider to draw some resonance for this, it is somewhat easy, but have to draw plenty of resonance structures. Okay, we have to draw plenty. Let's find out what are the resonance. Okay, let's find out. I can give these electrons to here, and likewise the previously I have told you that this method. Therefore this sulfur, this will be get the O minus, fluorine, double bond O, this is should be plus, F is not changed, and though this minus can be in here also, therefore I will draw another one. It means this oxygen is the lone pair is donated to this sulfur, and this will be broke, not this one. Therefore I will draw that sulfur. Now this is not broken, This is now O minus, and this is not changed, but the double bond is comes to here, the plus charge with fluorine. Right, this is two resonance structures. Therefore, again you can draw some what kind of this, because this fluorine is there with lone pairs, and sulfur can have up to 18 electrons. Hence, these only two of these electrons can be shared, can be donated to sulfur. Let's donate that one lone pair. You do not need to break any pi bond, because in here I am only doing the fluorine is donated. Fluorine donate කරන එක විතරයි මම කරන්නේ. මේ pi bond එක break කරන්නේ ඇයි? Because sulfur can bear electrons more than 8, right? Okay, let's draw that. O minus is there. This is oxygen, and fluorine now is double bonded. Two lone pairs is there, plus charge has come. Okay, and this should be what? Wait a second. Okay, this is then මෙතන double bond එකත් මෙතන මේකෙන් තමයි අඳින්න වෙන්නේ. මෙන්න මේකෙන් තමයි අඳින්න ඕනේ ඕක. මෙහෙම කරමු. මේක ඩොනේට් කරමුකෝ. මෙහෙම මේකත් මෙතන බ්‍රේක් කරමුකෝ. ප්‍රශ්නයක් නෑ. Right. Okay. Then this should be single bonded. This is okay now. Fluorine is there, right? Likewise, this one. This is true. Okay, this is true. Or else in here also you can draw like that one. මේක අමතක කරමුකෝ. මම මේ වැඩිපුර දෙයක් උගන්වන්නේ මේකෙන් තමයි ඇති. I'm drawing some resonance also. Donate this only to here. What will happen? Sulfur double bond O is there. This double bond comes. Two lone pairs, because one lone pair is donated. No, therefore to denote that donation, this should be in plus and this should be minus. This O and this should be fluorine. Likewise, this is also true. The overall charge is 0, minus plus 0. Okay, you have to always consider that overall charge should be 0. In here the charge is not given, it means plus minus should be cancelled out. Therefore overall charge is 0, right? But this is the stable one actually. These are comparing these two. Let's compare these two. Who's the most unstable one? The most unstable one is this one, because fluorine has the plus charge. In here the oxygen has the plus charge. Fluorine, the highest electronegativity fluorine, negative fluorine contain a plus charge. It means more unstable. This is the most unstable one. In here also fluorine plus got the plus charge in the fluorine. It is more unstable rather than plus charge in the oxygen. Right? Likewise. Can we draw another one? And here this can be drawn like this also. This minus charge will be there also. Sulfur, this is double bond, this is minus. This is double bonded F. So plus is there. This is oxygen and this is fluorine. මේ වගේ හිත අඳින්න ඕනේ. මොකද ඔක්ටෙට් ඕවර්කම් කරන්න ප්‍රශ්නයක් නැහැ නේ සල්ෆර්ට. හැබැයි මෙතන ඩබල් බොන්ඩ් එකක් දාන්න බෑ ඔයාලට. because oxygen cannot overcome the octet rule. මෙයා ඩොනේට් කරා විතරක් අඳින්න බෑ. මෙයා ඩොනේට් කරන්න පුළුවන් තනියෙන්. because fluorine can donate electrons and sulfur can accept, because sulfur is in the third period. It can overcome the octet. And another one can be drawn, I think, but this one. Likewise, can we draw that? Can we draw? This is O minus, nothing changed. This is sulfur, and this one is can become the single bonded. Double bond is arise to here. This should be plus. This is very unstable one, very unstable. Extremely. This is the most unstable one, because the fluorine and the oxygen, both of them contain the plus charge, and charge separation is also very high. Therefore, this is the most unstable one. Say 1, 2, 3, 4, 5, 6, 7 have been drawn. Those are the resonance structures of this. This is the most stable one. Only they have asking about this red colored one. Therefore, the marks will be given for that. Okay. To මම ඔයාලට මේ resonance structure සඳින්න මෙතනින් කියලා දුන්නේ. The sulfur contain වෙන නිසා you can draw plenty. It means ගොඩක් අඳින්න පුළුවන්. 7ක් විතර අඳින්න පුළුවන්. එහෙම අඳින්න එන්නේ නැහැ ගොඩක් වෙලාවට. මොකද එහෙම ඇඳ හිටියොත් මේ ප්‍රශ්නේ විනාඩි 15කින් කරන්න බැරුව යනවා. එතකොට අර වැඩිපුර ප්‍රශ්න අහන්න බැරුව යනවා මේ මොකද පේපර් එකක් හදන්න බැලන්ස් වෙන්නේ නේ. එතකොට මේකටම resonance අඳින්න ගියොත් එහෙම වෙන වැඩක් කරන්න වෙන්නේ නැහැ. Right. Let's go to the other one. This is you can see this is the first group, first period and second period containing element containing structure. Therefore, you cannot draw plenty. Just you have to proceed with my given structure. The previous week I have given a method to draw the resonance structures of these kinds of things. Very easy one. Therefore, let's do that. The most stable Lewis dot dash structure for this one is shown below. Draw 2 more Lewis dot dash structures. It is very easy. First thing we have to done is to you look at the double bonded one. In here you can see 2 nitrogen are the double bonded atoms, and you should then consider what are the atoms which are connected to those double bonded atoms. This is one and this is one, and both of them contains what? Both of them contain lone pairs. Then therefore you can draw 2 from this. 2 from this you can draw. Very easily can draw. එතනම දෙන්නේ කනින්න පුළුවන්. ඒ දෙකන තමයි ඔය අහන්නේ. Okay? Let's do that. මෙන්න මෙහෙම. Okay? Let's do. මේවට මුකුත් උන්නේ නැහැ. මෙන්න මේමයි. එතන මේවට මුකුත් උනේ නැහැනේ. අපි මුකුත් කරේ නැහැ. Right? This one is also nothing happened. And the nitrogen lone pair is there. This 2 electron is transferred to here. Now there's only single bond. Nitrogen. Nothing happened to this lone pair. In here now another single. Now there's a double bond because those 2 electrons has transferred to here. Now nitrogen, there's no lone pairs now because they are transferred. Hydrogen and hydrogen. Then you have to put the plus minuses as I have mentioned. Then here what happened? These 2 electrons has given by this nitrogen to this nitrogen. Therefore this should be plus. Then this should be minus. Then what happened in here? This lone pair is given by this nitrogen to this nitrogen. Hence this should be plus. This should be minus, but I told you to, after drawing this, cancel out the same when the atom contains the different charges, cancel them, plus minus to plus minus, cut off. Then now this is the correct one, and finally you can erase this also. Erase this. Now the correct answer is this is the correct answer. Right. Okay, give me a second for if something happens stuck. Alright, okay. In here again the same method. Now this is not like this. Now consider these are the 2 atoms I have mentioned. Now here this one is donated to here, and the double bond cut into this nitrogen. Let's draw that. H is nothing happened to H. 1 lone pair is being given now. The double bond has been formed now. Right. Then what happened? This nitrogen is there, lone pair is there. Now the one bond has been broken into nitrogen's head. That's why I'm going to draw from this. Okay. Then what happened? Then here nothing happened. Nothing happened. Okay. Right. Now draw the plus minuses, denotions. The lone pair is donated by this oxygen, this nitrogen. This is plus, and this should be minus. And this in here, these double lone pairs, these 2 electrons have been donated by this nitrogen to this nitrogen. And this should be plus, and this should be minus. Cut off. Same cannot be there. Now look at the overall charge also. Minus plus means 0. It means this H3NO is neutral one. Yes, it is a neutral one. This is here. They are asking write the unstable under the more unstable structure drawn by you. මේ දෙකෙන් කවුද වැඩිපුරම unstable? Consider this. Nitrogen minus is same, nothing to worry. In here nitrogen plus, in here oxygen plus. Highly electronegative oxygen has a plus charge. Therefore this is the most unstable one. This is the most unstable compared to this. This is less stable, this is unstable. This is a stable one. They have not in 2020 they have asked to write the less stable also. 2020 this is less stable, this is unstable. Okay. In 2019 they have only asked about the unstable. Okay. In 2021 they might ask to compare each and every one, like which I wrote in the previous. In here this is the least stable one, least very unstable. Likewise. So ඒගොල්ලෝ මේවා compare කරලා අහන්න පරිකමක් නැහැ ඉස්සරහට professors. Okay, let's move to the B3. I have quoted the answer sheets in here to hurry this. Based on the Lewis dot structure given below, state the following regarding the CNO atoms given period. These are the VSEPR around the atom. They are asking about VSEPR around this atom. This is VSEPR pairs. How many VSEPR around this? O1. Where's O1? This one. This one. Look at the O1 in here. How many VSEPR? VSEPR means what? Sigma plus lone. How many sigma? 1, 2. Lone 2. Lone pairs. Altogether 4. It means VSEPR pairs means lone pair plus sigma bonds. It means 4. Very easy. Let's find out the N2 here. N2 this one. 1, 2. This is a double bond. You know in the double bond pi and sigma is there. It means sigma 1, 2 lone pairs. It means altogether 3. C3. Pi bonds, 2 pi bonds are there. It means 1 sigma and 1 sigma 2. All there the meter pi and sigma නේ මෙතන තියෙන pi and sigma. it can sigma දෙකක් තියෙනවා carbon වටේට. එතකොට දෙකයි. එතකොට lone pairs නෑ යාට. N4 in here there are no lone pairs. There's a sigma bond in these 2 bonds. This double bond is the 1 sigma, 1 sigma, 1 sigma. It means altogether 3 VSEPR pairs. That's why. Okay, very easy these things. Electron pair geometry. When there are VSEPR 4 pairs and 2 sigma bonds, the shape is tetrahedral. You have to go through the resource book to find out the corrected shape. It means what? 4 VSEPR pairs, 2 sigma bonds. It means the shape is tetrahedral. Someone can say VSEPR pairs හදලා lone pairs දෙකයි ඒක නිසා tetrahedral කියලා මතක තියාගන්න ළමයිනොත් ඉන්නවා. කොහොම හරි ගමන්නේ මතක තියාගන්න. This one 3 VSEPR pairs. I have you should consider the electron pair geometry. It means it only need the VSEPR pairs. Sigma bonds කීයද ඒක වැඩක් නෑ ඒක shape එක කරන්න ඕනේ. එතකොට VSEPR pairs කීයද? 4යි. එහෙනම් tetrahedral. මෙතන VSEPR pairs 3යි නම් trigonal plane. Very easy these things. 2යි නම් linear, 3යි නම් trigonal plane. ඒක පොතේ එහෙම පිටින්ම තියෙනවා කටපාඩම් කරගන්න ඕන දෙයක්. VSEPR pairs 5යි නම් මොකද්ද? ත්‍රියානති ද්විපිරමීඩාකාර trigonal bipyramidal. VSEPR pairs 6යි නම් octahedral. ඔච්චරයිනේ. 2යි නම් linear, 3යි නම් trigonal plane, 4යි නම් tetrahedral, 5යි නම් trigonal bipyramidal, 6යි නම් octahedral. ඔච්චරයි. Those are the 5 electron pair geometries. Shape තමයි චුට්ටක් මතක තියාගන්න ඕන එක. අර මම කලින් කියපු විදිහට 4 VSEPR pairs 2 sigma, it means angular. This is 3 VSEPR pairs and 2 sigma, it means again angular. ඕක කටපාඩම් කර ගන්න ඕනේ. This is only 2 VSEPR, it means linear. Likewise, you have to go through the resource book and memorize these things. ඒක පොඩි බගුවක තියෙනවා, ඒ ටික බලා ගන්න හොඳට. අපි දන්නේ නැති කෙනෙක් මේවා දැන් පුළුවන් වෙන්න ඕනේ. Hybridization. VCPR pairs 4යි නම් මෙතන S අකුරු 1යි P අකුරු 3යිනේ. 3යි 1යි 4යි. S 1යි P 3යි. ඒකයි. SP3 4නේ මේ ඔක්කොම එන්නේ 4යි. මෙතන 3යි කියන්නේ VCPR 3යි කියන්නේ S අකුරු 1යි P අකුරු 2යි. SP2 මෙතන S අකුරු 1යි P අකුරු 1යි. මේ දෙක හදන්න මෙන්න මේ දෙකේ ඉලක්කම. මෙතනින් හදන්න 3 ඉලක්කම හැදෙන්නේ. එතකොට VCPR 3යි නම් SP2, VCPR 4යි නම් SP3, VCPR 2යි නම් SP මේක again SP2. Very easy these things. අපි VCPR pairs 5යි නම් SP3 D2 D SP3 D, VCPR 6යි නම් SP3 D2 or D2 SP3 කියලාත් පුළුවන් ප්‍රශ්නයක් නැහැ. ඒ විදිහට 5යි නම් 6යි නම්. හරි? මේ අපි නමුත් අපිට මේ එන්නේ මේ ගොඩක් වෙලාවට මෙන්න මේ වගේ SP3 and SP2 only ඔය තුන තමයි එන්නේ. ඉතින් හරි ලේසි. Right. Identify the atomic hybrid orbitals. Okay. Involve the following sigma bonds in the Lewis dot dash structure. FO. කො බලන්න මෙතන මේ bond එක හැදුනේ කොහොමද කියලා අහන්නේ. I told you that if you can, this is true. Both you can put, but the correct one is SP3. Corrected, very correct answer, because it is the second period. No, when the second period atoms are in there, they are going to form the hybridization, hybrid orbitals. It means SP3, because you know there are 4 VSEPR pairs. It means SP3. In here, we have found that there are 4 VSEPR. It always SP3. You cannot put 2p orbitals to atoms inside. ඇතුලේ ඉන්න කට්ටියට එහෙම දාන්න එපා. එළියේ ඉන්න අයට සමහර විට ඒගොල්ලෝ 2p orbitals දාන්න පුළුවන්. ඒයි කියන එක මෙතනදී කතා කරන්න යන්නේ නැහැ. නමුත් ගොඩක් වෙලාවට හැම එකටම hybridization ම දාන්න. එතකොට වැඩි ඉවරයිනේ. ඒතර VCPR pairs 4යි නම් SP3, SP3. O එකයි N මෙතන මේ bond එක. මෙතින් SP3 මෙයා SP2, VCPR 3යිනේ මෙයාට. SP3 SP2. N2C3 මෙතින් මෙයා एक sp2 में sp में carbon sp. Likewise this happens n4o5 में तम 2p තියෙන බලමු මොකද්ද කියලා n4o5 කො බලන්න n4 මේ දෙන්න. Both of them are in the second period, hence you should go for the correct හරිම ආන්සර් එක දෙකම දාන්න මේ hybridization. මේක sp3 දාන්න. එතකොට ගොඩක් හොඳයි. chlorine නුයි nitrogen මේ bond එක ගත්තොත් chlorine is the third period no. The correct very හරිම උත්තරේ 3p තමයි හොඳම උත්තරේ. The third period නම් යන්න atomic orbital එකට, second period කෙනෙක් අයිනේ ඉන්නවා නම් යන්න hybridized orbital එකට. මේක sp2 කමක් නැහැ ඉතින්. දැනට තාම A level syllabus එකේ මේ දෙකටම අයිනේ ඉන්න අයට උත්තර දෙනවා. ලකුණු දෙනවා. හැබැයි ඉතින් හොඳම උත්තරේ තමයි මම ලවුන්නේ. Identify the atomic orbitals involved in the formation of following pi bonds. Not about the sigma bonds, it's about the pi bonds. We know the pi bonds can be formed by the lateral overlapping of p orbitals. Pi bonds are එහෙමයි. Pi bonds are lateral overlapping of p orbitals. p orbitals කියන කට්ටියට පුළුවන් linear overlap එක වෙන්නත් පුළුවන්. ඒතකොට sigma හැදෙන්නේ මේක pi bonds. Because the shape එක මෙහෙම වැටෙන්න පුළුවන් මේගොල්ලන්ට. But always S forms because they are spherical in shape, therefore always it is sigma SS. May P wala linear, this is S wala linear, this is P wala lateral. Therefore 5 bonds always form from the d block orbitals and d orbitals and p orbitals. Double dumbbell එකකිනුත් පුළුවන් නේ d වලිනුත් පුළුවන්. Therefore NC ගත්තොත් they are in the second period. It means 2p. You have to write the 2. That is the, if you do not write the 2 in here, that's row. P විතරක් ලියලා හරියන්නේ නැහැ. Second period එකේ ඉන්න දෙන්නෙක් හැදෙන්නේ 2p දෙන්නෙක්. දැන් මේ N2C3 කෝ N2 මෙන්න මෙතන. මෙන්න මේ pi bond එක. pi bond එක හදුනේ කොහොමද? nitrogen ගේ p orbital එකයි unhybridized 2p orbital එකයි carbon ගේ unhybridized 2b orbital එකයි. ඒ කියන්නේ delocalized 2p එක. ඒතර ඒ දෙන laterally overlap වෙලා තමයි මේක හැදෙන්නේ. You have to write the 2 in here, not 3, because they are in the second period. Second C3N4 මේ දෙන්න. It is also double bond. It means it's a pi bond. P orbitals are overlapping. Carbon ගේ 2p එකයි, nitrogen ගේ 2p එකයි. Because they are sp2 hybridized. This one is sp hybridized. It has මෙයා ගාව දිනවා p unhybridized p දෙන්නෙක් ඉන්නවා. මේගොල්ලන් ඉන්නේ එක්කෙනා. nitrogen වලට ඉන්නේ එක්කෙනා. මොකද ඒගොල්ලෝ sp2 නේ. මෙයාට දිනවා දෙන්නෙක්. Likewise, you have to remember. These are very easy questions. How are the two double bonds oriented to the Lewis dot dash structure? That is very important one. This didn't ask for years. මේක කවදාවත් අහලා නැහැ. නමුත් මේක හරි පොඩි දෙයක් වුණා ළමයි ඉතින් මොනවක් හරි බොරුවක් ලියන්නේ නැති. නමුත් ළමයි වැඩි දන්නේ නැහැ මේ දේවල්. How are the two double bonds oriented in the Lewis dot dash structure given in part 3? Two double bonds means carbon ගාව double bond එකක් තිබෙ මෙහෙම n-ටයි කාටද සෙට් වෙලා තිබ්බේ n-ටයි n-ටයි මේ පැත්තේ නේ අර බලන්නකො එහා පැත්තකට ගිහින් මෙති මෙන්න මේක ගැන කියන්නේ two double bonds, right? This is sp hybridized. I think you know that these are very very important in organic chemistry. Cumulines are their example. Very famous example is the cumulines. I have mentioned that. These are the cumulines. ඒ වගේම කට්ටි cumulin කියන්නේ carbon carbon අතර double bond series එකක් තියෙන. එක ළඟ double bonds consecutive double bonds තියෙනවනේ, they are called cumulines in organic, but they are not in your syllabus, right? Not in your syllabus, but very famous one in chemistry. You can see these kinds of things, right? Central atoms is sp, they the same thing. මේ වගේ කෙනෙක් නෙමෙයි තියෙන්නේ, right? මෙතනදී බලන්න මෙතන දැන් මේ carbon මේ ඉන්නේ, හරි? මේ carbon is sp no, it means there are two p orbitals. මේ රතු පාටින් දාලා තියෙන්නේ මේ px එක තමයි මේ කියන්නේ මෙන්න මෙයා මේක තමයි එක p orbital එකක් එයාගේ, මේ අනිත් p orbital එක, හරිද? ඒ දෙන්න ඉන්නවා, හරිද? එයාගේ ළඟින් එහා පැත්තේ carbon කෙනෙක් ඉන්නවනේ. දැන් මෙතන නම් ඉන්නේ nitrogen කෙනෙක්. මෙයා sp2 අපේ example එකේ sp2. It means it also has p orbitals likewise, right? මෙයා හිටියට මෙහෙම කෙලින්, මෙයා කෙලින් ඉන්නේ නැහැ. එයා ඉන්නේ perpendicular විදිහට. මෙයා කෙලින් හිටියට මේ කාබන් කෙනෙක් දාලා මම example එක පෙන්නන්නේ. nitrogen තමයි අපේ සිම්පල් මේ පේපේකේ ඉන්නේ. මෙයා කෙලින් මෙහෙම හිටියට මෙයාට වඩා 90 degrees perpendicular විදිහට තමයි අනිත් එක්කෙනා. මේ විදිහට. ඒතර මේකේ කෙලින් ඉන්න එක්කෙනා යාට perpendicular විදිහට py දෙන්න මෙහෙම laterally attack මේ විදිහට overlap වෙනවා. මේකේ මේ විදිහට ඉන්න එක්කෙනයි මෙයයි overlap වෙනවා. ඒක තමයි කතාව. And also you should remember, not only the two pi bonds are perpendicular. Pi bonds දෙක විතරක් නෙමෙයි මේ කියන්නේ මේ pi bonds දෙක නෙමෙයි, මෙයා මෙහෙම මේ තියෙන මේ කළු පාටින් දාලා දෙන එක pi bond එකක්, මේ රතු පාටින් දාලා දෙන එක pi bond එකක්. ඒ දෙන perpendicular. Not only the pi bonds are perpendicular, but the two methylene groups are also in here. දැන් මේ cumulines වල මේ CH3 group එකක් හිටියොත් මේ විදිහට, දැන් මෙතන CH3 මෙතන දැන් මෙහෙම CH2 එකක් ගමුකෝ මෙතන. CH2 කරන්න. මේ CH2 දෙක ඉන්නේ. දැන් මේ CH2 මෙන්න මෙහෙම අනිත් එක්කෙනා මෙහෙම. ඒ කියන්නේ ඒ දෙන්නත් perpendicular. ඒක හරි වැදගත්. ඒ කියන්නේ එච්චර මතක තියාගන්න මෙයාත් මේ CH2 group එක මේ CH2 group එකට perpendicular විදිහට. මේ ඉතින් මේ AB මෙහෙම මේ කියන්නේ අංශක 90ට ඉන්නේ මෙයා. මේ ඇවිල්ලා එක pi bond එකක්. මේකට වඩා perpendicular විදිහට අනිත් pi bond එක පැත්තට හැරිලා ඉන්නේ මේ. මේකත් පැත්තට හැරලා ඉනකොට මෙයා කෙලින්. ඒ කියන්නේ මේකෙන් පොඩ්ඩක් තේරුම් ගන්න එක. ඒක පොඩ්ඩක් හොඳයි මේ ප්‍රශ්නේ. මොකද ඒ වගේ අහන්න පුළුවන්. මොකද 2019 paper නෝ. Double bonds are perpendicular to each other එහෙමයි. දැන් මේකේ මේ double bonds දෙක ඉන්නේ කෙලින් නෙමෙයි, එකිනෙකට සමාන්තරව නෙමෙයි, perpendicular විදියට. හරි? Right? That should be remembered. Read this. By pausing, read this. Okay? Give an example of a molecule ion that has a similar orientation of double bonds. මේ වගේ examples දෙන්න. මෙතන carbon dioxide, you know that carbon dioxide is like this. Okay. NO2 plus is like this. NO2 plus. CN2 minus how to draw? Carbon is there, Two minuses are there, and therefore you can draw minus in here. Nitrogen has the valence of 5, no? But minus is there, means the valencies have jumped to 6. Therefore you can put a double bond here and add those 4 here. Then the bond එකට දෙකක් ගියා, lone pairs දෙකයි ඔක්කොම 6යි. හරිනේ. මේකත් මෙහෙම දැම්මා. Right. Sorry, another. Like this is the Cn2 minus. Cn2 minus. Okay, this is, you can see another example. Double bonded consecutively. මෙතන තියෙනවා. And an N3 minus. N3 minus කොහමද අදින්නේ? කොහමත් N3ක් ඉන්න එපා. One is minus. It means I will put the minus in here. What happened there? There should be double bond now. එකයි දෙකයි කලින් එක වගේ. මෙයාට minus දාන්න බෑනේ දැන් මොකද? එක minus එකයි නේ තියෙන්නේ. Then what happened? Lone pairs are there. So in here also 5, the nitrogen has 5 valence. I have put that. You can donate these 2 electrons to here. Put that. Oh shit. Okay, let's put that. Make a donate කරමු අරකට. මේව දාමු. Dative bond එක. It means plus and it should be minus. Right? දැන් අපි මේකට නිකන් මේක තේරුම් ගන්න ලුයිස් ඩොට් එකක් අදින්න. look මේ dot cross එකක්. Dot cross nitrogen, this should be dot. මෙයාගේ මේ එකක්. හරි. මෙයා minus. ඒ කියන්නේ මේක dative bond එකක් අහලා තියෙනවා. මෙයා දීලා තියෙන electrons දෙක. මෙතනත් මෙයාගේ දෙකක් තියෙනවා. එයාගේ පහරින් 1 2 3 කතුරු වලින් පහරි හැමෝගෙම පහ හරියනවා. තිත් මෙයාට තියෙනවා nitrogen minus. හරි. මේක මම නිකන් ඇඳේ වට තේරුම් ගන්න. In here it has a dative bond also. But end of the day, we know that dative bonds are also after formation of the molecule. It acts as a Lewis covalent bond. Therefore, this is a covalent structure. You can see the 2 pi bonds are there. This is equal to the cumulines, which I have drawn in here. Cumulines. To the formation of this kind of perpendicular structure to reduce the electron repulsion and to form a more stable molecule. එක වෙන්නේ ඒකයි. මේ විදිහට pi bonds දෙක perpendicular විදිහට ඉන්නේ මොකටද? electron repulsion එක minimize කරන්න. Because when there are 2 double bonds are get together, the electron rich the carbon the මෙතන මෙන්න මේ area එකේ electron density එක increase වෙනවා. Therefore the repulsion forces also increase. To reduce that repulsion forces, they are being rearranged to somewhat the structure like this, perpendicular to each other. Perpendicular. Right? Very good thing to remember. It's a very important one. Alright, okay. එතකොට මේකේ කැමති එකක් නේ ලියන්න තියෙන. give an example one, anything. Okay. An atomic orbital is described by 3 quantum numbers NL, ML. Write the appropriate quantum numbers and the name of the atomic orbital in the boxes. In here, plus 1, this is 3p. It means it is 3p. It means the n should be definitely 3. මෙතන 3 නේ තියෙන්නේ. මෙතන 3, මෙතන 2 නේ තියෙන්නේ. මේ අනිවාර්යෙන් 2. Right? 3p orbitals. N equals 3 means what? L equals 0 to what? N negative 1. It means L කියන්නේ දෙන්නේ බිඳුව 1 2. බිඳුව කියන්නේ S. This was P, this is D. Right? This is plus 1 is here. Plus 1, 3p orbitals. 3p orbitals is plus 1. Plus 1, it means this is plus 1, 0, negative 1. It means it should be 1. This is L number 1. L වලට අපි value 1. These are what, which values? These are ml values. ml value plus 1 එක දීලා තියෙනවා. මේ L value එක එන එකගෙන් දා 1. In here 2 is there. N equals 2. It means L equals 0 and 1, because this is the rule. This is rule. This is S. This is P. This is B. Right? P. What are they asking? මෙතන මම මේ තුන්වෙනි එක කරන්නේ වැරදිලා. හරි. L number එකයි ml number එකයි අහන්නේ. 2s is given. It means L number is 0. This one also 0. මෙයාට 0 නේ තියෙන්නේ. මෙයාට 0 විතරනේ ml එක තියෙන්නේ. මෙයාට තියෙනවා +1 +0 and negative 1. මෙයා ගත්තොත් this n3 2 negative 2 in means අපි ගමු එක n equals 3. It means L equals 0 1 2 1 2. This is S, this is P, this is D. D means negative 2 negative 1 0 +1 +2. Okay, then negative 2 is, it means it is 3D. D orbitals නෙමෙයි D orbitals. Very easy. මේවා හරි ලේසි. මේවා මේ මොනවද මේ? මේවා ලකුණු ගන්න බැරි නම් වැඩක්. Okay. Arrange the following in this order the property of indicated parentheses. Reasons are not required. Melting points. Haha. Melting points. The cation is common. Oh no. In here cation is common. Lithium and lithium iodide. First consider the potassium and lithium first. Potassium, lithium is over. What happened? What happened? The atomic radius, what happened? Atomic radius increase. Potassium is somewhat larger, lithium is somewhat smaller. It means the polarizing power, what happened to the polarizing power? Decreases. When the polarizing power of the cation decreases, the polarization also decreases. When the polarization decreases, what happened? What happened? Polarization, covalent character decreases. When the covalent character decreases, ionic character increases. Ionic character increases. It means the melting point increases. Ionic character increase වෙනවා කියන්නේ ionic stability එක. Ionic character කියන්නේ ionic lattice energy එක increase වෙනවා. Right? එතකොට යාගේ melting points කොහොමත් increase වෙනවා. Potassium තමයි කොහොමත් වැඩි, කියන්නේ Kf වැඩි. Lithium fluoride lithium iodide ගත්තාම fluorine and iodide you should be considered because cation is common. Fi ගත්තොත් fluorine is somewhat smaller, iodine is somewhat larger. Aha. What happened? The atomic radius have increased of iodine. When the atomic radius of anions increases, the polarizability increases. It means polarization increases, covalent character increases. Covalent character increases, ionic character decreases. It means melting point decreases of this. Melting point decreases. It means Li should be here. This lithium fluoride should be. Okay. Stabilities you should draw what? The resonance, most stable resonance structure you should draw. NO2 minus means there's O minus there, nitrogen O minus should be there, other oxygen should be in the double bond. Now see the octet, it is true. 2 4 6 8 now okay, because nitrogen's valence should be 5. That's why I have put the 2 dots in here. Now NO4 3 minus. There are 3 minuses. It means 3 minuses are there, O minuses are there, O minuses are there. The remaining oxygen should be in the double bond. If you draw like this, what happened? 2 4 6 8 10, the octet is overcome. Hence you should erase one bond and put plus minus to indicate it is a dative bond. 2 electrons have been donated by nitrogen oxygen. මොකද එහෙම කරේ? අර මෑන්තොත් octet overcome වෙන නිසා IP එක ඉරාකම කරලා plus minus දාන්න ඉවරයි වැඩි. dative bond එකක් කියන්නේ. nitrogen මෙයා electrons දෙක මෙයා donate කරලා oxygen මේ share කරනවා නෙමෙයි තියෙන dative bond එක. nitrogen dative bond එකක් ගන්නවා. Therefore what is this? The very unstable, I can see this is more unstable than this one, NO2 minus, because the charge separation is somewhat very high. Let's focus on NF5. It is very unstable because it is not in the nature. NCl5, NF5 you cannot see. Because why? Because this is the octet have overcome 2 2 2 2 2. It means 10 electrons. It means the octet is overcome. Octet fulfill well. Octet එක පනිනවා. කොහොමද මේ වගේව නැහැ ලෝකේ. NF5, NCl5 not in the nature. Because nitrogen does not have d orbitals. Nitrogen in a second period එකේ නිසා d orbitals එයාට නැහැ. Therefore he cannot overcome the octet rule. Therefore NF5 is the most least stable one. ඒක octet එකවත් overcome වෙන නිසා තමයි most least උනේ. Therefore මෙයා එහෙම නැහැ. මෙයා octet okay, but its charge separation is somewhat high. This is somewhat stable compared to these three. Let's focus on this one. NOCl, NO bond distance. you should consider the resonance hybrid, not the resonance structure. Resonance hybrid is the correct one. You should consider resonance hybrid rather than going into the resonance. First you have to draw the resonance. NOCl, very easy, no, because there is no charge. It means oxygen should be in double bond. Chlorine is connected in a single bond. Chlorine always forms single bond in the stabilized section. Stability එකක් කියන්නේ stable compounds වල chlorine වගේ කට්ටිය single bonds තමයි හදන්නේ. NOCl. And there are no resonance structures either. Can draw a resonance structure which is unstable. If you can put this here and put it in here, somewhat unstable. No, this is the most stable one. NOCl3, let's draw NO double bond O, because there is no minuses. No, others should be chlorines. But if you draw like this, the octet will overcome 2, 4, 6, 8, 10. Then therefore the same thing to do. Erase a 1 and add plus and minuses to denote that a dative bond. And no, this is the, and you can see there are no double bonds in here. Therefore you cannot draw resonance structures in here. Resonance structures are in the double bonds. Nothing, right? It was the NO2F. NOOF. Again the octet has overcome. Again 2, 4, 6, 8, 10 වෙලා. එකක් මකන්න. එකක් මකලා plus minus. Okay. Again you can draw a resonance for this stable, somewhat stable one, because this minus can be here also. It means we can draw like this. Okay. It means O minus, N plus is there. This is F. This should be now double bond. Okay. Same thing. O minus charge is jump to this oxygen. This is stable. What is the resonance? You have draw the now resonance hybrid. Hybrid means hybrid again hitan අඳින්න ඕනේ නැහැ හිතන්න. Negative 1 shared by 2, it means that now negative half plus is there. Negative half. This is the hybrid. Aha. If you consider the bond lengths, the smallest one is the triple bond. This is somewhat larger. This is 2.5 bond එක. මේ double bond එක. මේ ඇවිල්ලා 1.5 bond එක. This is single bond. This is the bond length. Then you can see in here, you can see half 1.5 bond in between NO. Hybrid එකට යන්න. මේවා හිතන්න එපා. In here you cannot draw resonance, hence there's a single bond. In here you can draw resonance, but it is unstable. Hence for the resonance hybrid, the most stable one is contributing more. Hence this is the most contribution. The mean here two resonance are there, no, which are equal in stability. That's why you have to draw the two. But here මේක දාලා මෙතනට දැම්මක් කියලා ඒක මෙතන ඒක වැඩක් නැහැ. unstable එක ඇඳලා වැඩක් නැහැ. එතකොට මෙයාම වගේ කෙනෙක්ම තමයි. It means this is somewhat double bonded one. This is single bonded one. This is a 1.5 bonded one. Right? This is 1.5 bonded one. It means the single bonded one is the largest, because single bond නම් දිගයි. NO bond එක ගැන අහන්නේ. NOCl3 is the largest. Right? NOCl3 is the largest. This is double bonded. This is 1.5 bonded. 1.5. It means 1.5 is larger than double bond. It means who's the 1.5 one? NO2F, no? This one. NO2F. This means smallest one is NOCl because it has a pure type double. Pure double. Right? In here pure single bond. In here not a double bond either. Single bond. It means it is in between single bond and double bond. It means 1.5 bond එකක් කියලා හිතන්නකෝ. තර lazy. Okay. I think it's concluded. Okay. Let's start today's class. All the very best to you all. Thank you for the listening.